In this video, we're going to give an overview of sections 4.5 and 4.6, which are on dimension, rank, and nullity. Okay, so our goals for this section is we will first define the dimension of a vector space V. And the general idea behind dimension, we've actually seen this before in an earlier video in a previous section, is we're going to be interested in figuring out how large a vector space is. And usually we measure that by figuring out the size of a basis for the vector space. And that's what dimension is. How many things are in a basis? How many elements are in a basis for the vector space? So next, I want us to understand why the following chain of inequalities holds. So the number of vectors in any linearly independent set in whatever vector space we're talking about is always going to be less than or equal to the number of vectors in a basis, and that's always going to be less than or equal to the number of vectors in a spanning set. Oops, and I forgot to write one n in spanning. Let's fix that. In a spanning set. So next we'll talk about what are called the rank and the nullity of a matrix. And we'll talk about how they relate to each other. So one of those has to do with the column space, that's the rank, and what the dimension of the column space is. The nullity has to do with the null space of a matrix and what the dimension of the null space is. So after that, we'll do some conceptual examples that involve these concepts, so things like dimension and linearly independent and spanning. And then finally, we'll talk about something called the row space of a matrix. And we'll discuss how we find a basis for the row space.